So let's start coding the solution of our job shop problem. So first thing, let's just call our Jupyter Notebook file as job shop. We can call it main. And in general, what we will find that we have to always, like as a system or as a process, a procedure to solve optimization problems, we always have well, basically a seed or a data that we need to use. So first, get the needed data, and this is basically in our problem. It is that what kind of jobs and which machines we need to perform these jobs on, and for how long. So we need to define, we need to get these data. Now after that, what we will find is we have to define the variables that we need to optimize to solve our problem. That is, for example, starting time and the end time of every job, the total duration. For example, it's also a variable that, for example, this variable has to be reduced, has to be minimized. Also, we have to define the constraints, the constraint, and the constraints, that is, for example, the jobs has to be performed in succession. So job 0 and then job 1, and for job 1 the task 0 has to be performed, and then task 1, and then task 2, and so on. So this is it's important. And after that, we have to set the objective function. Now, setting the objective functions, that basically is, in our case, is to reduce the total duration of time needed to solve this problem. And then we have to solve them. We have to define a solver, and we have to actually solve this problem. And so here is going to be only define, and the solver is will be basically the iteration loops that is going to be performed in order to get our solution. And this is, most of the time, it is going to cost us the most amount of running time. Now after solution, we have results, output, and, well, basically after we optimize our variables, we just get them out, and we print them out, basically. So this is, let's consider it as the first or the general objectives of our in order to solve our problem. Now the first thing is we need to import, of course, as a Python, we have to import some needed libraries, and here we will import collections. And collections is a library that deals with lists and dictionaries. We will use parts or some of the methods in the collection libraries. However, it will be explained more in later classes before using them directly. So the explanation has to be like continuous. So for now, let's just import them. And the other thing is Google OR tools, and here OR tools, the way we import it, is from OR tools.sat, because we're going to use CPSat module or CPSat solver. We import CP model, and we shift enter, and having this without error, that means we imported the library, as well as like the OR tools library, as well as the collection library, without any problems. So the first step we need is to get the needed data, and getting the needed data is, in our case, we will define them. Of course, later in this course, we will actually get a CSV file as a data. But for now, let's just focus on the optimization, focus on the problem itself, and later we will do that. So don't worry about actually importing actual CSV files and playing with them, pre-processing them before actual machine learning part. We will do it later in this course, but for now we'll just going to write our own data. So we will write what the exact problem we have. So jobs data equals, now we open a list, and during this list we will have 3 different jobs. So we have the first job, and enter. This is the 3 jobs we have, and so here you can see this is going to be job 0, and here job 1, and here job 2. Now job 0 will have this elements, which is 0, 3, 1, 2, and 2, 2. So machine 0, 3 hours, machine 1, 2 hours, machine 2, 2 hours. And here the same thing. We have 3 tasks, and again we have another 2 tasks as the last one, 1, 4, and machine 2 duration 3 hours. For job 1, we will go here from machine 0 for duration of 2 hours, machine 2 duration 1 hour, and machine 1 duration of another 4 hours. Now the number of machines is machines count equals 3, and we need another list that has all the machines. All machines equals 0, 1, and 2. So machine 0, 1, and 2. So here we define our problem. So shift enter to run it. And now what we're going to do is we need to check what is the worst possible solution. So the worst possible solution is basically doing these on series. That is doing, for example, or starting from job 0, we will have we go to machine 0 and we run this one, and we stop all other machines, and then we'll go for the other one, and then we run on machine 1, and then this one, and then this one, and then this one, and this. So we take every task and do it, and then stop everything else except this task. And by that we need to see how many, what is the duration that the worst solution, the worst possible solution, this is going to be our benchmark, and we're going to use it also as a variable to define the starting and to define the solution variable. For example, the start of these jobs. As we said, this is an integer value problem, and defining, even we have only integer, but we need to define the range of values. So having the ultimate range of the worst solution is going to be beneficial for us. So to do that, we need to define variables. A variable we call horizon, and let's say we define it as 0, but what we need is we need a function in order to actually count these tasks like the tasks duration. So horizon equals 0. What we need is we need to loop in the jobs. So here we will write job in this, which is jobs data, and then we will loop again into, now when we loop into the jobs data, we will take the first element and then the second element and then the third element, and within that we want to take these smaller elements, so we will loop through them. So for it will be task in, we want to loop through this, which is job, because we will loop into the first element and then the second, the third. In job, what we will need is horizon, or that variable should be, well, equals plus equals, which is horizon equals horizon plus the task, which is this one. And what we're interested in, not in everything, what we're interested in only the time duration. So it will be 1. If we set 0, it will be well, basically it will give us this number, which is, we're not interested into it. We're interested into 1, this number. And of course we can print horizon. We have error for job and jobs data name print. Sorry. Yeah, so the worst possible solution is 21. If you want to see how these things work, you can just simply print the jobs and then comma jobs and also task. If you also want to see what's happening or how these print statements are, what's going on inside the loop, you can just print them. And as you can see, the first job here is going to be the first element here, and then the second loop is going to take the first of these elements, and then second, and then third, and of course he will assign that number, this number, onto horizon. And this is how we proceed into how we do our how we calculate the horizon final value.